asked you to take the two graphs we looked, or the two equations we looked at yesterday, find the X and Y intercepts, and use the information from yesterday to graph the function. First of all, how do you find X and Y intercepts in general? Set the other variable equal to 0. If you're trying to find an x-intercept, you set y equal to 0. If you're trying to find a y-intercept, you plug in 0 for x. So let's start with the y-intercept. If I plug in 0 for x in this first one, what do I get? -1 on top.
Over -6.
1, 6. Does everyone agree? If I plug in 0, I get a 6. Question? Was it the x or the y? Y'all tell me what is that? Y-intercept. Looks like 0 in for x gives me the y-intercept. This part.
Plug in 1, 6 for the x.
Yep. What do I do next? Find the x-intercept. So this is old stuff. First. Go ahead and make the y value 0. So I want to know when this equals 0. Now this is new to you. When is a fraction going to equal 0? You're close, Alex.
Oh,
when the top is 0, like 0 divided by anything is
0.
As long as it's not 0 over 0, as long as it's not a whole, right? So would you agree 1 would be the x-intercept? Now I do have to be careful on the other one because remind me from yesterday, what happened to that x minus 3? It was a hole. A hole is an undefined place. You can't have an x-intercept at a hole, so there is no x-intercept here. Because once I cancel the x minus 3, there's nothing left on top to make it equal 0. If I tried to plug in 3, I'd get undefined. I'd get an error. Where here, if I plugged in 1, I'd get 0. No x-intercept. The y-intercept, how did I find the y-intercept again? Plug in 0. -3 divided by -6 is 1/2. So now I'm going to put on paper everything I know, and then I'm going to have the calculator fill in the gaps. Those of you who had pre-AP Algebra 2 last year, you didn't get to use a calculator to fill in the gaps. You had to fill those in all by yourself. So you do get to use a calculator, but the calculator's not perfect. Y'all saw that yesterday. It doesn't show you holes. It has struggles with asymptotes. It's just not perfect. So we're going to make the calculator better. So the first thing I'm going to do is plot the x and y intercepts. Now, I found those by hand. Could you have found those in the calculator? Yes. I'm going to plot the asymptotes. Someone with their notes out, remind me what the asymptotes were on this graph. Sure.
How come there's no x-intercepts on the second row?
I thought it was 3. But 3 was already a whole. Yesterday we did these problems and we identified 3 as the whole because of that factor that cancels. And so it's undefined. And here's a way to check. I can take the 3 and plug it back in. If I do that, I get undefined. And since you will be using a calculator in combination, that'll be something you'll probably notice pretty quick when you try the 3. It doesn't give you 0, like you would hope it would. And I'm going to find holes first, and then I'm going to mental note if it's a hole, it can't be an x-intercept as well. Okay. Has someone figured those out yet? -2 and 3 were the vertical asymptotes. So I'm going to put a dotted line at -2. I'm going to put a dotted line at 3. We also had a horizontal asymptote. What was it? 0. Why is it 0? And the denominators, degree of the denominator is bigger than the degree of the denominator. Those are the vertical asymptotes. Remember yesterday. Now, I am using yesterday's notes. If you didn't take notes yesterday, this is probably, you probably feel a little bit lost. You need to take notes. Yesterday, we identified the vertical asymptotes as x equals -2 and x equals 3. You remember that from yesterday? And so, I put those in there.
Do you know x equals 3 is a whole of it?
It's not on the left one, on the right one it is.
Oh, yeah.
We'll talk about that in just a second. So I'm going to graph this. Pull your calculators out. Graph this on your calculator. I'm going to use the guidelines I have up here to make it accurate, but then I'm going to use the calculator to figure out where it is on that. Does anyone have a calculator that doesn't have a fraction key? The alpha y equals fraction key. Use the fraction key to graph this. You can graph the original. You don't have to. You can do it in original or factored form either way. There's only one graph, but there are 3. Yeah.
So we just kind of tell you when we're drafting.
Yes. What I expect to be accurate on your graph. You tell me, what do I expect to be accurate? The asymptotes, the intercepts, right? That's what I expect to be accurate. Other than that, I'm going to sketch what I see on my calculator screen. Does anyone not quite see this picture? Is anyone's calculator like stopping on the asymptotes or anything?
Actually, just draw it.
Right, the calculator doesn't do a great job of asymptotes, so you have to know to put these arrows on the ends. I will expect to see that. Your graph needs to look like my picture up here. Any questions? If you're graphing by hand, you've got the asymptotes. Remember when we got the domain that had those 3 pieces? That's how you know there are 3 pieces. There were 3 pieces to the domain. And then if you were graphing by hand, solely by hand, you'd have to point plot to figure out where those were. So it would take you a while. It'd be more tedious. And we don't have to do that in here. So that took a little on that. Any questions about this one? And let's look at the next one. On your homework, you're welcome to graph it first. Just make sure that the asymptotes and the holes are in the right spots, right? So the first thing I'm going to do is plot everything I know. You can graph it as I'm plotting, and then we'll look at the calculator. There were no holes on this one. Okay, so someone with the information written down from yesterday's notes. Remind me, asymptotes, holes, all of that information for the second graph. Where were the asymptotes? X equals -2, and only at x equals -2. And the hole was at 3. I'm going to remind myself of that. I don't know exactly where the y value is. If you wanted to find that by hand, you would cancel the x minus 3 out and then plug in the 3 and give you 1/5. But we're just going to use the calculator to estimate where that hole is. The horizontal asymptote was still at y equals 0. If you look at a calculator sketch, and we also have the 1/2, the y intercept, no x intercepts, but we do have that y intercept. If you look at the calculator sketch, it looks like this, except I'm going to put a hole in it. You see where I just drew that little hole there? At 3, I'm going to indicate that there's a hole there. Your calculator's not going to do that. I want to see that. I want to see that you know there's a hole there. If you forget, go back and go, oh, there's a hole, and just erase a little spot and draw an open circle to indicate that there's a hole there.
There's only a hole, like,
Right. And you're going to have to identify that because your homework tonight looks identical to your homework last night. just at a graph at the bottom. So you'll find the holes, you'll find the vertical asymptotes, you'll do all of that, and then you'll sketch. So you'll have it, the information sitting in front of you. They might have, yeah, they cleared them when they did the, but we can get them back. When they did the part testing, they cleared them.
Are there any programs for this?
Not unless you write one. Not any I'm aware. No, I say there's none. People write them all the time. Okay, let's look at this one. Again, it's another problem we did yesterday. Look back at your notes. Quick reminder. We had a horizontal asymptote at y equals 1. We had a vertical asymptote at x equals -3. And we had a hole at x equals 3. Do I need to go back over why any of that is the case? Just for some extra information, now again, you could get this from the calculator, but you could go ahead and find the x and y intercepts. The y-intercept, you would plug 0 in for x, and it gives you -6 over -9, which is +2, because the negatives would cancel. 0 2/3 is the y-intercept. And the x-intercept, now remember, I can't use holes, so what's the only x-intercept up there? -2. X-intercept is what makes the top equal 0.
You get that again.
When does the whole function equal 0? That happens only on when the top equals 0, the fractions are 0 when the top is 0. And so then the x plus 2 will tell. Again, check all of this information in the calculator. If you accidentally get your vertical asymptotes and your...
I need to see the following students in the office. Will Fitzgerald, Bailey Miller, Shay Hewitt, Max Higgins, and Andrew Martinez in the high school office.
If you accidentally get your vertical asymptote and your x and y intercepts incorrect when you do this by hand, will you notice that in the calculator? Probably, we hope so. So you can kind of fix some of your mistakes by being able to use the calculator. Everyone okay with where I got my asymptotes? Y equals 1, x equals -3. There is a hole at 3, so I'm going to go now to my calculator, and I notice that my calculator looks like this. When I come to 3, I'm going to put an open circle there to indicate that I know that there's a hole there. And do what?
So those things are weird.
They are a little strange. Again, you notice I'm not being real careful on the rest of it. As long as you're careful on asymptotes, holes, and the intercepts would be nice to put on there at least close to the right spot. The rest of it, I'm not going to be real picky on. I'm not going to make you be so tedious to point plot. So, any questions so far? Okay, this one I'm going to need a lot of help from the calculator on. We didn't learn how to do slant asymptotes in this class, and this one has a slant asymptote. So we're going to have the calculator compensate for the things we don't know. So we're going to graph it. Now I can find the x and y intercept. It's actually pretty easy. The x and y intercept is, what do I get if I plug in 0? 0. If the y-intercept is 0, then the x-intercept is 0. Does that make sense? Okay, and then there's nothing else on top. There were no asymptotes. There weren't any horizontal asymptotes. There weren't any vertical asymptotes. So by hand, I'm stuck. Calculator. Do what?
I've already got the graph.
Good. And we're just going to use the calculator to graph it. We're going to rely solely on the calculator. Now what you will notice even though we're not going to learn how to find them, you notice this follows a slanted pattern, kind of like a line. So it has what's called a slant asymptote.
How do you find those?
You have to do polynomial long division. It's not horrible. You've done it before in algebra 2. So you sketch the graph from the calculator. Okay. If you come to one that has no asymptotes, then we're not gonna be as good at this graph because we don't know as much about it. Any questions about that one?
So basically, just for now, just adding the.
Just putting the graph. And we're gonna be accurate on asymptotes, things like that. Our calculators aren't real accurate on this. You can't really tell where the asymptotes are. We're going to draw those dotted lines to see that. Okay, last one. This is the one from the last one from yesterday. Someone remind me, and I'll factor it to remind you. I'm shortcutting the factoring. We did this a little slower yesterday. What were the asymptotes? 2 and negative 2 both, vertical asymptotes. Horizontal was y equals 2. We didn't find this yesterday, but if we wanted to, we could plug in 0 for the x's and get the y-intercept of 1/2. Just for an extra point to plot. X-intercepts, yes.
On the top of what was that to be x plus 2?
You have to do a greatest common factor first.
Since that equals -2, and 1 or -1 is just got 8.
But then you get this 2 in front. So it distributes in. So factor out the greatest common factor first, and then do the difference of perfect squares.
Real quick, could you explain horizontal?
We look at those rules. The degrees are the same. And so we do the ratio of the leading coefficients 2 divided by 1. Also, I could even find the x-intercepts on this one pretty easy, 1 and -1. Look at the graph in the calculator. That is that.
Your y was what?
The y-intercept was 1/2. You plug in 0 for x. Now I'm plugging 0 in for x by hand because it's pretty easy to do. You can just get rid of all the things with x's in them and divide the constants. But if you forget how to do that, couldn't you plug 0 in for x in the calculator as well? Okay. To the right of the graph, where is it? Those of you who have it in the calculator. Isn't that really what I need to know? I kind of know it does something like this. I just need to know whether it's up there or down there. 2 up. I better check my work.
You're trying at the x-intercept?
That's right.
Do you use the numerators or the...
The numerator. Because you want to know when the function equals 0. And when do fractions equal 0? So that's the 1 and the -1.
So when you're doing these
Say it again. Well, remember yesterday when we found the domain, and we said the domain was -infinity to -2, -2 to 2 to infinity. So you're seeing that those 3 pieces. That one of this one back here, it had a hole. So one of those things that we thought might be an asymptote wasn't. We still have a break in the graph because we have the hole. So there's still technically 3 pieces, but you don't see it as much because there's the craters, just that little bitty hole instead of the big vertical asymptote.
Oh, so the hole will be, what the hole would be.
That's right. And that example would come from here. Here's an example where the only thing I did to the problem different was I changed the x minus 1 to an x minus 3. And it caused a hole. So it changed this graph to look like this. So just that minor change making an asymptote to a hole makes a big difference. Okay, any questions? I'm going to pass out your homework and I want you to get started. We've got like 20 minutes left in class, so about 10 minutes worth of time that you can ask me some questions.